Hi, everybody. In this video, we are going to be talking about several different topics. You can kind of see them all listed out about the top of the screen there. So we're going to be looking at the adding integers, real numbers. We're going to be subtracting real numbers. And we're going to be multiplying and dividing real numbers. So this topic we go through a little bit faster because we have already talked about adding and subtracting numbers, adding and subtracting fractions. We've talked about multiplying and dividing fractions. The only change up now is that because we're talking about real numbers, we are including all of the numbers that are on the number line. So we're adding in negatives, including in addition to the positives. So we've already talked about all of these operations, adding, subtracting, multiplying, dividing, all with positive numbers so far, and now we're going to throw in the negatives. So that's really the change up, which is why we go a little bit faster through these, because the main skill you guys are needing to pick up on is what happens like when we subtract a negative, or what happens when we multiply by a negative, or multiply two negatives together. So those are the skills that will be a little bit different, or the new information for this topic. So the first thing we are going to be adding in here, it says review of rules to add is our first blank. To add two numbers with the same sign, whether it's both positive or both negative, you are going to add their absolute values. Oh, that's not going to fit in that blank. Absolute values, and give the sum the same sign, meaning if you are adding two positive numbers, so let's say if we have like this, 2 plus 3, well then the sum, which is our answer, so we have a positive plus another positive, our sum is going to have a positive answer. So we know that one. Well, here's the other one. Let's say we are taking -2 minus 3. What it's telling you to do is to say, take the absolute value of -2. So the absolute value of -2 is 2. And the absolute value of -3 is 3. And it says to take their sum, which means we're adding them. So 2 plus 3 would give us 5. But our sum here is going to have the same sign on it that our two starting numbers had, which is negative. So anyway, that's what that's talking about. We have dealt with negatives. I mean, like you guys have dealt with negatives in your past that I'm sure you guys are also thinking, Liz, we're just taking -2 and then we're subtracting 3. And that's exactly right. And you would get -5. So if you remember all those rules, that's great. Okay, so the next thing, it says to add two numbers with different signs, where one is positive and the other one is negative. We are going to find the difference. So that's subtraction. Sorry, that is so messy. Let me rewrite that. Find the difference of their absolute values. Again, that's their distance between that number and 0. Find the difference of their absolute values by subtract a lesser absolute value from the greater one. So take the smaller one from the larger one and give the difference, which is going to be your answer, right? It's the answer to a subtraction problem. Give the difference the same sign as the number with the greater absolute value. So for example, if we've got -5 plus 2, because the larger value, like the larger absolute value. So, okay, back up. So if we take the absolute value of both these numbers, absolute value of -5 is 5. Because remember again, just definition of absolute value. Absolute value, by the way, is those vertical bars like that. It asks the question, what is the distance between -5 and 0? So if -5 was over here, it's saying, what is this distance right here? And you would say it's 5 units. So here, if this absolute value of -5 is 5 and the absolute value of 2 is 2, you're saying, well, which one of those absolute values is the larger one? And it's the -5. And so that means the sign of my answer will also be negative. And that makes sense, right? Because if you're at -5 and then you add 2, 1, 2, that gets me over here to -3. And so that's going to give me a -3. So that's what it's talking about. Conversely, I mean, you guys have done this one lots of times. So if we had 5 minus 2, we would say, okay, well, the absolute value of 5 is 5. The absolute value of -2 is 2. The larger absolute value is 5. It's positive. So my answer will also be positive. 5 minus 2 is 3. So that's what these rules are talking about. I'm hoping most of this is somewhat familiar to you. And so hopefully it's making sense. All right, number 3. It says to subtract a negative number. To subtract a negative number, change the subtraction sign to an addition sign and add the absolute value of that number. So this one's saying if you subtract a negative, so 5 minus a -2. We change the subtraction sign to an addition sign and we add the absolute value of this negative. Well, the other way we've seen this before a lot is like 2 negatives make a positive. So what we end up doing is we end up saying this. So minus a negative is going to be positive, and that's going to give us +7. All right. So then the product or quotient, so this is multiplication, quotient is division, of a positive, here's positive, and a negative number is a negative number. And then the product, again, this is multiplication and quotient, division, of a positive and a positive number will result also in a positive number. And then our last one, the product and quotient of a negative and a negative number. So if we've got negative and negative, it's going to end up being a positive number. Okay, so what that means, I'm going to draw in some little examples in here. If we've got, so here's an example for this top one. If we've got, what did it say? Positive and a negative. So if we've got 4 divided by -2, that's going to give us -2. I'm going to sneeze. Whoa. Oh my goodness. Whew. Okay, no, I'm not. Sorry, excuse me. Or if we have -6 divided by a +3, that's going to give us a -2. If we've got, and this one we've done lots, if we've got a positive by a positive, that's going to result in a positive. We've done that before. If instead we have -15 divided by -3, that's going to give us a +5. And so far, all I've done is division. So we're finding a quotient, right? Well, it works the other way too. If we've got -15 times a -3, that's going to give us a +45. Because the negative times the negative is going to give us a positive. Okay, so here we go. It's our little chart here. So it's saying a positive times or divided by another positive is going to give us a positive. And I'm going to give you this little chart because I think 1, it's kind of funny, and then 2, it might help you remember it. So I'm going to give you some different headings here. Apparently I can't draw parallel lines, and that's okay. Nobody's judging me. All right. This is good things or bad things. So I'm just going to write good or bad things. And this is good or bad people. And this last one is how we feel about it. Sorry, I kind of weird that up. How we feel about it. Okay. So get this. When good things, because our positive is going to be good things, when good things happen to, positive is good people, how do we feel about that? So when good things happen to good people, we feel pretty good about that. It's positive. We like that. Let's look at the next one, see how that one shakes out. When good things happen to bad people, how do we feel about that? Okay, I'm not condoning this kind of thinking. This is not endorsed by the math department of UMW. It's just kind of a funny little thing that will hopefully help you remember this. Okay, back to the story. When good things happen to bad people, well, we don't really like that. We're like, why are they getting those good things? They're not a very nice person, or they're doing these terrible things to other people. Why are they getting all these good things? Bah. Okay, let's see about the next scenario. When bad things happen to good people, oh gosh, I hate that, right? Like I hate it when bad things happen to exceptionally good people. It makes me feel super sad. So wah wah, it's another negative. Okay. But when bad things happen to bad people, sometimes we kind of like that. It's a little, maybe this little devil inside of us, we kind of like that. Okay, again, I'm not endorsing this kind of thing. It's just something that I think is kind of funny. So when bad things happen to bad people, we kind of like that. Also, it helps us fill in our chart. And maybe it helps you remember what happens when we multiply or divide by positive and negative numbers. All right, so let's look at some examples. First example, we've got, and by the way, if you run out of room, there's more room on the next page, on page 46. Because we are going to do a bunch of examples. All right, number one, we're taking negative 27 and we're adding a negative 138, and then we're adding a 55. And so these honestly become like a calculator exercise for you guys. So you can grab out your calculator, and there's a whole bunch of ways you guys could think about doing this. One way is you could start with your positive, and you could say 55 minus 27, and then adding a negative, that's the same as subtracting. So adding a negative, that's the same as us just saying we're going to subtract. And then so it'd be 55 minus 27 minus 138 gives you should end up with negative 110. Alternatively, if you wanted to, you can start with 27 and make it negative. The little calculators that I have, they've got this little plus minus button that looks kind of like that. Your calculator might have something that looks a little bit different, but it allows me to punch in a number like 27, and then I hit this key, and then it makes 27 negative. And then what I would do is I would subtract 138, and then I would add 55 to it, and I would still get the same answer, negative 110. So hopefully that's what you guys got too. That's the right answer. So always do these yourself as well. All right, next one, we've got negative 3/7, and then we are adding a negative 6/7, and then we are adding 2/7. So this goes back to our work with fractions. And again, first thing you should check is, okay, we're adding, subtracting, which means I need to have a common denominator, and that's so great. I do, I've got a common denominator. So then again, same thing. You can look at the numerators and say, well, I've got negative 3 minus 6 plus a 2. That's all over 7. Negative 3 minus 6 gives me negative 9. Negative 9 plus 2 is going to give me a negative 7. And negative 7 over 7, go back. We've got a negative. We're dividing by a positive. That's going to result in a negative. And 7 over 7 is 1. So our answer is going to end up being negative 1. Next one. Then we've got negative 23 2/3 plus a negative 16 1/2. And that's the problem. We're not adding or subtracting anything else. So again, what I would encourage you to do is say, okay, well, I'm subtracting fractions. And yes, I know your calculators can do this type of problem, but you need to be able to do it by hand and kind of like show your work in here. And there's a time that you can, like, portions of this problem you can do just straight in the calculator. But you have to show your work on how you're getting there in the steps, meaning like this. So you should recognize, well, because we're adding or subtracting fractions, we have to get a common denominator. And so when I look at these, I think 3 and 2, okay, I'm gonna get a common denominator of 6. And so I'm gonna say negative 23, and I'm gonna put a 6 here, which means I'm multiplying this by 2 and this by 2, which is gonna give me 4. And then adding a negative means I'm subtracting. So then I'm gonna get minus 16, and then 1/2, that's the same as 3 over 6, right? So that's times 3 times 3. So then what I am thinking about is the fact that they're both negative. So both negative means essentially what my brain does, my brain adds them, adds the two numbers, and then I know that my answer will be negative. So here I'm thinking about the fact, and if you want to, change them into improper fractions. So if you are an improper fraction person, you can totally go, okay, 6 times 16, and don't look at that negative. You're thinking about 6 times 16 plus 3. So times and plus, and then you're putting it right back over 6. And then here you're doing 6 times a positive 23 plus a 4, and you're putting it right back over 6. I personally keep them as mixed numbers. So I do 23 and 16. So 6 and 3 is 9, and 2 and 3 is, or sorry, 2 and 1 is 3. It's still going to be negative. And then I've got 4 and 3, which is going to be 7 over 6. And I look at that and say, okay, that's not quite right yet. So let me fix that. And I end up getting negative 39. Hang on one second. Let me write this a little bit easier so it'll make more sense. I'm still going to have my negative out front. And I'm going to have 39 plus 1 and 1/6. So it's going to look like that. So then I end up getting, so 39 and 1 and 1/6 is going to be 40 and 1/6. And the answer to that's going to be negative overall. So then my final answer is negative 40 and 1/6. Again, if you would prefer to change them into improper fractions and just go that way, go for it. That's what you should absolutely do. All right, so let's look at another example. Next example, we've got another fraction, negative 2 3/4. And this time we are adding 7/8 to it. We are adding 7/8. So here, I'm going to go ahead. I'm going to show you the improper fraction way, just to give you that way as well. So I look at this and say, okay, I've got my denominator 4. I can multiply it by 2, and I'll get a common denominator. And then I'm going to get negative 2 6/8 plus 7/8. And I'm going to go ahead and change this into improper fractions this time just to show you guys. So 8 times 2 is 16. 16 plus 6 is going to give us 22 over 8, and that's going to be negative. And then I'm going to add 7/8 to that. And then you can do this one of two ways. My brain likes to do this. My brain actually likes to do, because I see that there's a negative and I'm adding a number, my brain actually goes 22 minus 7, and then I know that my answer will be negative, because that goes back to the rules up here, that if we are right in here, so we're finding the difference between their absolute values. And so that's what I was doing. I was finding the difference between their absolute values, and then whatever my answer is, it's going to have the same sign as the larger number, or as the larger absolute value. And so again, my brain goes 22 minus 7 is going to give me 15, and then I know it's going to be negative. Or if you prefer, you can say negative 22, put that on the number line, and then add 7. It's going to get you up to negative 15. And then that's your final answer, negative 15 over 8. Or if you would prefer, you can write negative 1 7/8. So either one of those would be correct. All right, let's try some more. Here's one. This one's a little bit different than what we've been doing. This one actually says find negative 22 1/3 minus x when x equals negative 41. All right, so if we're given something like that, we need to take negative 41 and plug it in for x. And then mind the fact that we have a negative here already in our expression, and then we've got a negative over here on the 41. So we're going to go negative 22 1/3 minus, and then here I am putting the negative 41 in, negative 41 like that. And then that minus a negative ends up becoming a positive, right? So we've got negative 22 1/3 plus 41. And again, you can say, well, maybe let me switch those around, and maybe if it's easier for you to think about the fact that that's actually like 41 minus 22 1/3. So here's what my brain likes to do. My brain likes to say, what's 41 and what's 41 minus 22? And say, okay, well, that's going to be 3, and then I carry the 1 over, and that's 9, 10, 11, 1. So that's 41 minus 22. That's going to give me 19, but I'm also subtracting 1/3. So then let's subtract 1/3 from that. And that's going to end up giving you 18 2/3 from that. And again, I'm just thinking about the fact, like, picture 19 whole pies, and then you take away 1/3 of one of those pies. How much is left? It would be 18 2/3 would be left. So we've got 18 2/3 for our answer. If you are like, Liz, I can't picture that, I don't like that method, you are always more than welcome. Remember, we can also go like this. 19 0/3 would be my fractional part of that 19. And then I would say, okay, let me borrow here. And I'm going to cross that off. And that's going to become 18 3/3. I'm hoping you remember that from several sections ago. So I'm hoping everybody also sees 18 3/3 is 19. So I didn't do anything weird. And then I'm subtracting 1/3. And so 3/3 minus 1/3 gives me 2/3. 18 minus 0 is going to give me 18. And that gives me 18 2/3. So that gives you just another way to say, like, okay, I don't do well picturing it, Liz. What's another way I can do it? You can do it like that. You can also change it into improper fractions. That will work as well. Okay, I'm skipping around a little bit. I need to cross off the one that I did not do. Let's try this one. So this is my number 7, but we're going to make it's your number 6. So it's going to be negative 23 3/10, and then plus 16 minus a negative 32 minus 4 1/5 plus 6. Okay, so what I would like for you all to do at this moment is pause this video and try this one out on your own. So pause this video, try it out on your own and see how you do, and then hit play again and watch me in hyperspeed and jump to the end of it where you see the answer and see how you did on that one. Actually, I'll just tell you the answer so you know right away. We should be at the end of this getting 26 1/2. Yes, 26 1/2 is the answer we should be getting. So ready, set, go. Pause the video, and then I'm going to work here on this problem. Okay, so a couple things that I'm thinking about is that my brain kind of sorts these things, and I sort them into, here's a whole number, another whole number, and here are my fractions. And I'm going to kind of sort them so that I get them, I don't know, in a better order that I like better. I'm also going to clean up some of these minus and negatives because that's going to be a positive. So I've got 16 plus 32 plus 6. And again, I've had students say, Liz, it's really hard for me to remember where the signs are all going. If you need to, I've told students before, you can kind of like draw vertical lines between each of these, because the signs, as long as we've got addition, subtraction going all the way across, those signs are going to travel with those terms. So it's plus 6. And then I'm going to jump over here and it's minus 23 and 3/10. And then it's minus 4, and I'm going to go ahead and get a common denominator here of 10. So that's times 2 times 2, and it's going to be 2/10. Okay, so then what I would do here is take your 16 and 32 and 6 and go ahead and add them all up. So if we've got 16 and 32, 6, 7, 8, 3, 4, and then we're adding, what are we adding? We're adding another 6 to that. So that's going to give us 54, because 8 and 6 is going to give you 14. And then carry that 1, and it's going to give you 5. So we've got 54 from the purple numbers here. And then we are going to be subtracting. We are subtracting 23 and 4. So again, my brain is it's adding these together. 23 and 4 is going to be 27. And I know my answer is going to be negative. So it's 27. And then 3 and 2 is 5/10. And so that's going to give me 1/2. And so here I'm going to take 54 and I'm going to subtract 27 and 1/2. And if you want, at this point, you could punch it into your calculator if you wanted to, and you could say, well, let me just double check. You could say, well, let's check it and say 54 minus 27.5, and bingo, that gets me 26.5. And that's your answer. 26 and 1/2 is the answer. And again, if you're like, wait, I want to be able to show in my fractions, you can always go like this. You can go 54, and actually back that up. I'm going to write 53. 53 and 2/2. And then I would subtract 27 and 1/2. And then you're still going to get 26 and 1/2 from that. All right, let's try another one. This one is totally a calculator problem. So 32.6 minus a negative 14.1. This one is having you practice your positives and negatives. Minus 2.9 plus a negative 82. Ready, set, go. Pause the video. Go and do this one. This one really is just you punching it into your calculator. You should be getting negative 38.2 for this one. And again, just in terms of watching out, this minus the negative, so it'd be 32.6 plus 14.1 minus 2.9 plus a negative is going to be subtracting 82. And then when you get done with all of that, your answer should be negative 38.2. If it's not, double check your calculation, because it should be. All right, here's one, same type thing. It's having you practice multiplying it, or you can also do some mental math here on this one. So I'm going to do, we've got 3 times negative 6 times 2 times negative 3 times a negative 1/2. Okay. So here's what my brain does. My brain looks across this and says, okay, all I've got here is multiplication, because that's what the parentheses are doing. The parentheses are breaking all those numbers up, and you are just multiplying. Excuse me. That's exactly the purpose of those parentheses. It's to tell you, to communicate to you that that's what we're doing, is multiplying. So then I look across and say, how many negatives do I have? I've got 1, 2, 3. So if I have an odd number of negatives, my answer is going to be negative. If I have an even number of negatives, my answer is going to be positive when you're multiplying across like that. And that might be something you jot down if you don't remember. So odd number of negatives when you're multiplying straight across, your answer is going to be negative. Even number of negatives multiplying straight across, your answer is going to be positive. And the reason why is because negative times a negative would give us a positive. And then a positive times a negative is going to give us a negative for our answers. And that's why. And that's why that rule works out that way. Okay, so as I'm thinking about this, my answer is going to be negative. And then I don't know, maybe we just go straight across. 3 times 6 is 18. 18 times 2 is 36. And then I've got times, what did I get to? I still have times 3 and times 1/2. So then my brain likes to take, well, let me go back and take half of 36. And half of 36 is going to give me 18. And then multiply it by 3. And what should we be getting? I think 54. 24, yeah, 54. So you should be getting negative 54 for that one. If you're not, double check your calculations there. Let's try a couple more. I'm looking for which one we want to do here. Okay, let's try this one. So we've got negative 28 2/5, and we are going to divide it by 4/3. All right, so here, common error again is that students will take 5 times the negative 28. Don't do that. Think about that negative being on the outside. And so we are going to take 5 times a positive 28 plus a 2, and we're going to put it right back over 5. So it's going to be, again, we're going to do 5 times 28 plus 2 all over 5. This is going to be negative. I got to move my equal sign over so that you can see that. Negative. And then we're dividing by fraction. So don't forget, we keep, we change, we flip. So changes to multiplication and we flip to 3/4. So as we do this multiplication and then we add here, we should end up getting negative 142. If you're not getting negative 142, double check your calculation. Negative 142 over 5 times 3/4. And then multiplying straight across, you should get negative 426 over 20. And then you can, if you want to, you can reduce at that point. For sure, we can take out a 2 and you can reduce at that point, or you can change into a mixed number, and we should be getting negative 21 3/10 for that one. And you'd actually get, so when we're changing that, by the way, you'd actually get negative 21 6/20. And then you would need to reduce by 2. And so that's how you end up with the negative 21 3/10. Last one. Which one do I want to do? I have 3 more to choose from. All right, we'll just do this one. All right, so we've got 24 1/2, and we're dividing by negative 2 5/6. Negative 2 5/6. So pause the video. See if you can get this one done. You should end up with negative 8 11/17 for your answer. So pause the video. Ready, set, go. All right. I'm hoping you change this first. So we're going to multiply. We're going to add. We're going to put it right back over 2. We're dividing by another fraction here. So what I would tell you to do is that I would change this fraction into improper first, and then we're going to flip it because we're dividing. So we're going to keep, we're going to change, we're going to flip. So here we go. 24 times 2 should give you 48 plus 1 is 49. So you should get 49 over 2. And then our 6 times 2 is 12 plus 5 is 17. So we're going to divide by 17 over 6, and that is negative. And then we're going to keep, we're going to change, we're going to flip. So we're going to have, we keep the 49 over 2, we change this to multiplication, we flip it. So now we've got negative 6/17. You know, we could reduce some here. We could take out a 1. That would be a 3. And then the answer I got was not, was not reduced. So hang on one second. Let me figure out this. 49 It's going to be close to 150. All right. So we've got negative 147 over 17, or you can change it here into this mixed number. So either one of these would be correct. Whichever one you choose, doesn't matter. You can leave it as improper, or you can change it to a mixed number, or you can do both. Your options, your choice, I mean. All right, so typically in class, what I would have you do is I would have you guys try working on this together with your partner, your elbow buddy, and see how you guys do on these problems. And then we would go through and check them. So what I would like to do is I'm going to go through and I'm going to write down the answers. And I want you guys to pause the video and see how you do on these. So this first one should be negative 6 degrees Fahrenheit, average in Boston. That's your answer. And then this next one is negative 299.01. And that's dollars. Don't forget your label. Our next one is a 95 degree Fahrenheit difference. The next one is 79 degrees Fahrenheit. And then our last one, you actually have a couple of ways you could express your answer. One way you could, you're kind of coming up with 0.17 per 1, or you're thinking about the slope that it's negative 1/6 inches per year. So either way. All right, now you've got the answers. Pause the video, see how you do. And then I'm gonna walk through them as well in case you miss any of them. All right, so Boston is on average 7 degrees warmer than Bangor, Maine. Excuse me. The low temperature on one cold winter day in Bangor was negative 13 degrees. About what low temperature would you expect Boston to have on that same day? So Boston is typically 7 degrees warmer than Bangor, Maine. And we know that Bangor on this particular day was negative 13 degrees. So we are taking negative 13 and we are adding 7 to it, which gives us negative 6 degrees Fahrenheit in Boston. Let's go to Boston. My husband did some time on the East Coast, like he spent some time on the East Coast. That made it sound like he was a convict. He is not a convict. He did some time. No, he's not a convict, but he spent some of his childhood on the East Coast. And I don't know if you know this about the East Coast, but apparently if you go to Dunkin' Donuts and you ask for a donut with sprinkles, they're going to look at you like you're a crazy person. And sprinkles are called jimmies. I don't know why. So you need a Long John, you need like a, and I don't think they call them Long Johns there either. So if you want a donut that has sprinkles, you have to say, yo, I need a donut with some jimmies on it. And then I guess you get a donut with sprinkles. Unless my husband's playing a cruel joke on me, which he could be. And I just shared it with you all. All right, then let's check the next one. It says Everett paid several bills without balancing his checkbook first. Uh-oh. When the last check, that's like a major no-no. Don't do that. Or like your debit card. Who writes checks these days? We do Venmo or we do like PayPal or something. You have to check your balance first, right? Well, when the last check he wrote was still to be deducted from his balance, Everett's account was already overdrawn. Oh, the balance was negative $201.35. That's serious. The final check was for $72.66, and then another $25 is going to be subtracted as an overdraft charge. What will Everett's account balance be after that last check and the overdraft charge are deducted? All right, so first of all, terrible accounting going on here. Like, don't let this happen to you. Negative $201.35 already in the hole. That's terrible. All right, so he writes a check. for $72.66. So that's being withdrawn. Oh my gosh, you're going to be in so much debt. That just stresses me out. All right. And then because the bank penalizes you because they're like, yo, I don't want to cover your debt, but that's what they're doing. They're covering your debt, or they're covering Everett's debt at this point. They're like, not cool. So you also get a $25 fee. So you're subtracting that as well. Punch it into your calculator. I personally, because I see that they're all negative, I would do 201.35 plus 72.66 plus 25. And then I know that my answer is negative. So then my answer would be negative 299 bones and a penny. That's bad. I feel bad for you, Everett. Hopefully that's a life lesson and that doesn't happen again. All right. One winter, Phil flew from Syracuse, New York to Orlando, Florida. The temperature in Syracuse was -20, and the temperature in Orlando was a blissful 75 degrees. What was the difference in temperatures between Syracuse and Orlando? This problem sometimes causes students problems. So what I would like you to do is think about it in terms of like almost like a thermometer. So up here would be 75, right? And then here's 0. And then here is that -20. This is a serious packing challenge. So you start out at -25, or sorry, -20, and it's asking what's the difference between here. And so if you wanted to, you could say, well, what's 75 minus a -20? Because we're finding the difference between those two. So it'd be 75 plus 20, which is going to give us the 95-degree Fahrenheit difference. And that's your answer. All right, next one. It says, during a storm, the temperature dropped by 0.5 degree every minute. At the beginning of the storm, the temperature was 83 degrees Fahrenheit. An expression giving the temperature in Fahrenheit T minutes after the storm began is this. And so right here, it's actually gave you the expression that matches all of this information. So 0.5 degree every minute is that -1/2. And then the 83 is, this 83 is right here. So then it says, what was the temperature after 8 minutes? So here we just need to plug the 8 in for the T. So we're going to do -1/2 times 8 plus 83. And essentially you're asking yourself, what's 1/2 of 8? 1/2 of 8 is 4. So -4 plus 83, and that is going to give us 79 degrees Fahrenheit for our final answer. All right, last one. So it says, over the course of an 18-year research project, the height of an oceanside cliff dropped due to soil erosion. Oh my goodness. At the end of this period, its height was measured as -3 inches compared to what it had been at the beginning of the research project. What was the average amount that the cliff's height changed each year? So we're doing like height each year. So what happened with the height of the cliffs, or the height of the cliff over the amount of time? And so it dropped in 3 inches over how many years? And it was 18 years. So it's going to be like this. And then we're going to reduce. And so it's going to be, well, we're losing an inch every 6 years. Or you can think of it in terms of it's 1/6. We're losing 1/6 of an inch per year. I know some students don't like the fact when I leave it like this, like -1/6, and they're like, wait, it should be per 1 year. Well, if you want to, you totally can. You can say, well, that needs to be divided by 6, divided by 6. And what do you get? You end up getting this right here. You're going to get that answer. So you're going to get, and I'm sorry, this should have been negative in here. So hopefully those of you that made it to the end of this video catch that. That should be negative. And so if you divided it by 6 to get that unit rate, that's what you're going to end up with, is this one. Or if you left it like that because you interpreted your answer correctly, that at the end of this, that actually means you're losing 1/6 of an inch per year. That's great too. Okay, that's it for this video. Thanks for tuning in.